Thank you very much. Welcome to the YUIConf Gala Costume Masquerade. It's great to see all of you here in your festive costumes. You all look fabulous. So we are here at YUIConf at Yahoo's, where are we? Great America campus in Santa Clara, California. Tonight, Section 8, JavaScript programming style in your brain. Now this might seem sort of three unusual things to talk about in one talk, that how could these things possibly be related to each other? JavaScript and brains? What's the connection? Well, there actually is a connection. JavaScript and programming style and brains? Yeah, there's a connection, and it's an important connection, and surprising, and hopefully entertaining. So this talk comes from a scientific discovery. There were some social scientists who were doing some work, as they do, in trying to understand human intelligence. How do we think? How do our brains work? And they came up with a set of simple experiments, and their results were really surprising. So they published the results, and the scientific community said, that can't be right. There must have been an error in the design of the experiments. There must have been some error in the evaluation of the data. This cannot possibly be the correct explanation for how we think. But the results were at least interesting enough that other people attempted to replicate the studies and then did follow-on studies and new experiments. And the conclusion was, yeah, it's true. We actually think like this. So this is sort of how science works, where someone will come up with an experiment which has a conclusion which contradicts what is commonly understood by the scientific consensus, and it will immediately be challenged, but then we'll try to replicate, and if it bears out, then the scientific consensus changes to adopt that until further experiments will contradict again. And then there's a Nobel Prize. And all of that happened in this case. This is how science happens. So this is all told in a wonderful book, The Science of Fear by Daniel Gardner. Gardner talks about this research and its implications on society, and the fact that because of the way we think, we tend to misunderstand what danger is, and we fear the wrong things. The consequence of fearing the wrong things is that you actually put yourself in greater danger. Great book, I highly recommend it. So what was this discovery that was so amazing and unusual and probably true? It was that there are two systems in the head. System 2, or in the brain. System 2 could be called the head. It's where we do analytical thinking. It's where we do arithmetic and mathematics. It's where we think deep thoughts. And it's great, but the problem with it is it's kind of slow. And it's because the head is kind of slow that we had to invent computers, because the modern world demanded a lot of number crunching, and we are just not very good at that. So we needed machines that were faster than we were at doing that stuff. Then there's System 1, which could be called the gut. It's evolved from the flight or fight response. It is very, very fast, but there are trade-offs in the way it's fast, and so it makes mistakes. So if you ever saw a cat who's just standing there and suddenly he freaks out and runs, and then he stops and goes, yeah, I meant to do that. That's the flight or fight response. And the biases in that system are set so that false positives are okay, because it's better to get a false positive than a slow positive, because then you don't have time to get out of the way of whatever's at you. So you'll see a flock of birds suddenly take off for no reason, they come back. That's that mechanism, and we got that. So the gut is really fast, but it's only approximate because it doesn't know arithmetic. It can't solve hard problems, but it's not trying to solve hard problems. It's just looking for certain kinds of patterns, and when it sees those patterns, it reacts. Now, neither the head nor the gut are surprising. I mean, we all know about that. My head tells me this, but my gut tells me that. We're always experiencing that kind of stuff. The surprise in this research was the connection between those two systems. It turns out that the gut informs the head. The gut sets up the assumptions that the head is going to use in doing its computation. And the head is not generally aware that that's the case. and that the things that the gut tells the head are weighed more important than things that the head itself has experienced. And that makes it really easy to confuse people by confusing their guts. Now, this was news to the scientific community, but there is another community which has known about this stuff for a long, long time. And that is, of course, the advertising community. They figured this stuff out decades ago. This is not news to them, because a lot of their business is selling stuff to us that we don't need. They create wants for things that we don't really want. How do they do that? You don't do that by talking to the head. You do that by talking to the gut. And nobody is better than the tobacco industry. Because you look at tobacco, what does tobacco do? It makes you smell bad. From the first time you light up, you stink. I mean, that's tobacco does that. Then your teeth turn yellow. Then you get sick, and then you die. That's what tobacco does. So how do you sell a product like that? You don't sell it to the head. You sell it to the gut. So if you ask a smoker, why do you smoke? Well, why? That's an analytical question, so that goes to the head. But the head is going to now start thinking with facts that it got from the gut. And the gut says cigarette smoking is not dangerous. Because the way the gut looks at danger, it's looking at immediate danger, it's looking at shocking danger. Slow death doesn't register. So slow death is as good for you. If that weren't the, and if you have any logical system and you start with false premises, you can reach a false conclusion. I mean, we know that logic tells us that. But that's how we think. So you can ask a smoker, why do you smoke? And you could be sitting with them in a restaurant and say, well, if we were rational, you go, I smoke. Well, that's stupid. I should stop immediately. But that's not what happens. Instead, he's trying to think, why do I smoke? There must be good reasons for it. It makes me popular. And he'll say that, not noticing that the healthy, good-smelling people who are near him are trying to get away so he doesn't taint his food. So people will smoke until it kills them, until they die. And most smokers will, and you could say, well, that's because of nicotine addiction. They're addicts, that's why that happens. But that doesn't explain brand loyalty. Most smokers will stick with the brand that got them hooked until it kills them. That's not addiction, that's something else. That's some confusion that's happening in the gut. So let's switch for a minute and talk about computer programs. Completely different topic. Computer programs are the most complicated things humans make. We don't make anything else which is complicated as programs. Programs are made of a large number of parts, usually expressed as statements or variables or functions or other things. And they all have to work together in a way which is amazingly complicated. There's nothing we do that's more complicated than software. You could point at systems which are very complicated, like an airplane is very complicated, and that's true. The most complicated component in an airplane is the software. And that's true of all systems today. Software is complicated. And people are not good at that. So early on, when we started programming, there was this idea that programming is just too difficult. We should write programs that can write better programs than we can, because people are just not very good at this. And once we can get the programs to do that, we can then tell the programs, make a program that's better than you. And we keep doing that until they become our overlords. That didn't happen. Artificial intelligence failed. Artificial intelligence has done a lot of amazing things. It can play grandmaster chess and a pretty good game of Jeopardy now, but you can't give a set of requirements and customer interviews to a computer and have it write the program for you. They can't do that. So we're still writing programs by hand. We've made extremely small progress in the evolution of technological thinking around programming. The most powerful tool we have is the programming language. And so that is a partnership between us and the computer, where it's doing some of the work, we're doing some of the work. The programming language allows us to work at a higher level of abstraction, which allows us to be more productive, but still, basically, it's handmade stuff. And programming languages are extremely important in that they control or shape the way that we think about things. And sometimes that's a really good thing if the programming language helps us to organize things well. But they can also create blind spots in us. So if you're using a programming language that does not offer recursion, you're not aware of what a valuable tool recursion is. Or if you have a language that doesn't have closures, you're not aware of what a valuable tool closures are. So programming languages work for us and against us. The thing that makes programming so difficult is it has to be perfect. A program has to be absolutely perfect in every detail for all possible inputs and all possible uses, even including uses which were not anticipated in the design of the program. If any flaw is found in the program, the computer has license to do the worst possible thing at the worst possible time. And it is not the computer's fault. Whose fault is it? It's the programmer's fault. It is the programmer's fault for having created a program that was not perfect. So you would think that the way we should do this stuff is we should hold on to the programs and keep working on them and refining them and cleaning them until finally they are perfect, and then we'd release them. And we don't do that because we would never release anything. So instead, we put out stuff which is known to be imperfect and just hope that we get away with it, that we won't find a bug in it until the next cycle. And sometimes we get away with that, and very often we don't. And so we have this problem of perfection. Humans are terrible at perfection. We are greatly imperfect creatures. I am a very imperfect person. But I program, so because we got no one else to do it. We are hunters and gatherers. And I don't mean that metaphorically. There has been no human evolution since the Paleolithic era. We are those guys. We got their brains. We were selected for running around. Our heads were designed for thinking about strategies for getting food, and our guts were designed to get us out of danger when the predators were coming after us. We're using that brain now to program computers, and there's no reason to think that that should work. And somehow it does. It's miraculous. It's crazy. So we're using everything we got. Obviously we're using our head to do the analytical stuff that it can do. It needs to keep the problem and the state of the program and all of the stuff it's working on. You try to keep the whole model in your head so you can reason about it. But if you try to teach programming, it's really hard. We don't have an algorithm for how we do it. As we're decomposing a problem, sometimes we're going top down, sometimes we're going bottom out, we're going inside out, outside in. We're constantly changing strategies as we're working on this. Nobody can describe how we do that. Somehow we all figured it out, and we do that every day, but we don't know how we do that. And it occurs to me that it must be the gut that's allowing to do that. It's the thing that shifts us from one strategy to another, that gives us the occasional flash of insight which makes the whole thing work, that we could not program without our gut. I have absolutely no evidence to justify that statement. But my gut tells me it's true, so I believe it.
That's for sure.
So much of the craft of programming is making trade-offs. There's never a perfect solution to anything, which is one of the things that makes perfection unattainable. So we're constantly having to trade off, space for speed or other things. And the gut, unfortunately, is extremely bad at making trade-offs. And so sometimes the gut, instead of helping us, significantly hinders us. And we'll talk about some of the consequences of that. So the programming language I'm going to use for examples tonight is JavaScript, obviously. But the things I'm going to talk about are applicable to all programming languages. It's just JavaScript is kind of special, partly because it has good parts. I can tell you that I discovered that JavaScript has good parts. That was the first important discovery of the 21st century. And everybody has discovered for themselves that JavaScript has really bad parts. JavaScript was designed in about 10 days. And somehow in those 10 days, Brennan and I managed to get some good parts in it, and they are really, really good. But he got a lot of bad stuff in. There's just not time to try it out and make sure it worked right, and it doesn't, and it's horrible. My first couple years working with JavaScript were extremely painful, partly because I decided not to learn the language before I started working in it, which was about as stupid a thing as you could do. I did that. But I kept running into all these sharp edges that the language had, so I decided I needed to make a tool to help me manage this crazy language. So I created something called JSLint. I started with a Pratt parser. Pratt parsers are amazing things. You can write compilers really efficiently. It's a lovely technique. I owe you a talk on that because it's fascinating. Just a little bit of fluff and suddenly you've got a compiler. It's great stuff. And so having this a JavaScript compiler written in JavaScript, I decided to make a lint tool out of it to help me find problems in my programs because there were a lot of them. And I started hanging out on comp.lang.javascript, which was Usenet. Anybody remember Usenet? That's still, yeah. So, people would come on and say, hey, my program doesn't work, and they'd post it. And so I'd take it and throw it in JSLint and see if I could automatically figure out what the problem was. And sometimes I could. And sometimes I couldn't. Sometimes the way they were coding was just so complicated or so error-prone that there's no way you could tell if it was right or wrong. In cases where these examples suggested rules, I'd put them into JSLint. In examples where there weren't, sometimes it suggested a discipline. And that if you had a discipline, then it would be possible to determine if that was right or wrong. And so the program evolved that way. When I started, I had no plan for how JSLint was going to grow. It basically grew in response to the things I was learning on comp.lang.javascript. So JSLint comes with a warning. JSLint will hurt your feelings. And this is true. This is absolutely true. I hear from people all the time, wow, JSLint's, You wouldn't believe how much mail I get from people whining about, JSLint, So I go, oh, wait a minute. Now let's look at this. So JSLint is a code quality tool. Its intention is to help people become slightly more perfect in their programming. They're running the program on purpose for that purpose. Why are they complaining that it's telling them how to make their programs better? And I think there's some interference going on with the gut, that the gut is telling them that they're doing things which are bad. I determined these things were bad empirically by looking at bad programs and tried to identify flaws in bad programs. And they haven't been through the process that I have, so they just don't understand why JSLint is telling them to do the things they're doing. We've talked about this argument. Should curly braces be on the left or the right? When Ken Thompson designed the B language, he decided to put them on the right. They could be anywhere. And when the late Dennis Ritchie did the C language, he copied Thompson's syntax, so he put them on the right too. But there were guys in their lab who wanted to put them on the left because they thought it looked better. They probably argued about that for a week and then said, leave us out of this, because this is a stupid argument. There is no reason for why you should do it one way or the other. There isn't. There's no argument which is right or wrong, left or right. It's completely arbitrary. It's like driving, should we drive on the left or the right? The British can demonstrate that you can drive on the left. We drive on the right. It's okay. It's good that there aren't any roads connecting us with England because we don't have to deal with that. So it doesn't matter which side we're on. It's just that we all be on the same side. I told that story in Bangalore, and it was like confusion. What are you talking about? So if you have someone who's always put them on the left come into a shop where they put them on the right, and they say, you got to put them on the right now, he'll start to cry. Go, no, no, I'm not going to put them on the right. That's so wrong. Can't you see how wrong that is? And he'll start making up reasons. So the head is now working, trying to figure out, why is it wrong? And it's trying, oh, it's more readable, or you can line things. And he gets more frustrated because it doesn't make any sense. And he might even hear himself saying these things, and no, this doesn't make any sense. But there's got to be a reason, because why would I be this passionate? Why would I be crying if this weren't important? Yeah, and we like to think we're rational. We're programming computers. We're analytical. We're mathematicians. We're laying this stuff out, and we're crying because we had to move a piece of punctuation from one line to another. There's something else going on here. And so ultimately, I don't know what the right answer is, except in JavaScript, where in fact we have a right answer. You want to put them on the right. Oh yeah, you got to be consistent, no matter what you do. No, everybody will agree that it looks stupid to sometimes put them on the left, sometimes put them on the right. You got to be consistent. It's like driving. You got to always do it the same way. And everyone will agree that everybody should do it like they do it. But we can't agree on how it should be. I think Thompson did the world a disservice, and he could have easily fixed his B compiler and say, it's got to be on the right, damn it, and shut up, where you get a syntax error. End of story, but he didn't. So he left it sloppy, and so that introduced some personal expression into the thing, and so we can't agree. And partly we can't agree because there isn't a right answer, except in JavaScript. Because of semicolon insertion, which does this stupid thing if you have a return statement that's returning an object literal. Instead of returning an object, it returns undefined. You get no compile time warning, no runtime warning. Your program may not fail at the point here. It may fail some minutes later, which makes debugging really hard. And in debugging, if you finally track it down to this line, you can look at that for hours and not understand what's wrong with that. That should work. So this is due to a terrible design error in JavaScript. This was a blunder. It's awful. But if you always put your curly braces on the right, you will never suffer. Once after explaining this at a talk, someone came up to me and said, wow, that thing about the return statement, that is so right. So from now on all my return statements, I'm going to put them on the right, but the rest of the time, I'm still going to put them on the left. So prefer forms that are error resistant. For no cost, if you just say, I'll do this thing for which there isn't a right answer, do it this way, you avoid a terrible problem. And the net cost of doing that is zero. So if you look at it in terms of trade-offs, this is a good trade-off. For zero cost, big benefit, you're trying to be perfect, this is good. Now, your gut might be saying, oh, this is so wrong. Can't you see how wrong this is? The gut is really bad at making trade-offs. But the gut will tell the head, yeah, we're making a good trade-off. But you're not. So the switch statement, I have to tell the switch statement story again. So early in the development of JSLint, someone wrote to me and said, there's a problem with the switch statement. The switch statement was designed by Thompson. He modeled it after the Fortran computed goto statement, which is now recognized as harmful. But that hadn't been completely accepted yet. So there's this go-to-ness in it, in which you really don't have a set of cases. You've got a set of labels, and the code will fall through to each other. So it's really a computed go-to statement, which is terrible. And you can have fall-through going on. And this guy wrote to me and said, that's sometimes a problem, where looking at the code, it's really hard to see where the fall-through occurs. And that can be a difficult thing to debug. And so your lint program should warn about that. And I thought about it. And I wrote back to him and I said, well, yeah, that's true. I've seen it. But that hardly ever happens. And on the other hand, you can optimize the flow going through all these cases. And that can be quite elegant, and there's value in that. So looking at the trade-off, I think it's probably better not to warn on that. Okay, next day, the same guy wrote to me and said he found a bug in JSLint. So I'm always happy to hear that. So I threw the debugger, and it turned out I had a case that was falling through. And in that moment, I achieved enlightenment. We'd like to think we spend most of our time power typing. Yeah, I'm being productive, I'm writing programs, but we don't. We spend most of our time looking into the abyss, saying, my God, what have I done? How am I ever going to make this work? And once we figure it out, we forget that we did all of that. It's sort of like the way we forget the false positives that the gut triggers. Because if we observed all the false positives, then the gut couldn't work anymore, because we'd be analyzing our reactions instead of responding, which is what the gut wants us to do. So I got that really wrong. So what was my mistake? That hardly ever happens means the same thing as it happens. This is the gut talking. The gut is confused about number. The gut thinks that a lot has more value than all. The gut thinks that not very much or not very often is the same as none or never. That's not true. I mean, mathematically, we know that's not true, but the gut tells us that. And so that caused me to reach a very wrong conclusion about the safety of switch statements. Now, normally when we make mistakes, we just forget about it and keep going. We spend most of our time making mistakes, not power typing. And because there's something wrong with us. I used to think that everybody should learn programming. When I first started learning it and thinking about how to organize the world in terms of data structures and algorithms, I thought, wow, this is such an amazing way to organize information. Everybody should learn to do this. I don't think that anymore. I think there has to be something seriously wrong with you in order to do this work. That a normal person, once they've looked into the abyss, will say, I'm done. I'm not. This is stupid. I'm going to go do something else. But not us, because there's something really wrong with us. A good style can help produce better programs. Style should not be about personal preference or self-expression. Some people think that style is the stuff in your program that the compiler ignores. And because the compiler ignores it, you got license to do whatever you want with that, because it doesn't matter. It's not part of the important information. So you can structure it any way you want, just to show off or to amuse yourself or to express your individuality. That's not what it's for. Let's talk about style. The Romans wrote Latin all in uppercase with no word breaks or punctuation. They were the biggest empire in the world at one time. They did fine with this. It's definitely harder to read from our perspective. Like on the third line, you could read that as now or DB reeks. So you have to work a lot harder in order to parse the text and understand what it says. Now, this worked fine for the Romans up until about the time that Constantine established Christianity as the state religion of the Roman Empire. At that point, it became necessary to replicate all of the holy documents and distribute them over the empire. And there's a problem, because they didn't have the originals of any of these documents. All they had were copies of copies of copies, and none of the copies agreed. And that was a problem because they were claiming their spiritual authority on the written word, and nobody was really sure what the written word said. So they decided, well, we need to get better at this. And it turned out this style of writing was contributing to the problem. This turns out to be really hard to copy by hand accurately. So medieval copyists introduced lowercase, word breaks, punctuations, in order to improve their error rate, that it made it easier to extract the information from the texts and to copy them into good copies. And it worked. This was a very effective way at making their copying much more reliable. Gutenberg copied this convention when he laid out his Bible, and it's been in printing ever since then. It's on the internet now. This is the way we do text. Not just in religious works now, but in academic work and popular work, fiction, everything uses these conventions because they work. We've been using these now for many centuries. It's a good idea. And I think to the extent it makes sense, we should continue to use these in programming too, because the most important thing for a program is that for people to understand it. And this is a convention that people can understand. We have centuries of evidence about it. But what they demonstrated was that use of good style can help reduce the occurrence of errors. And since we're going after perfection, we want a style which helps us to do that. There have been lots of books written about style in literature. One of my favorites is William Strunk's Elements of Style, very influential. It was written almost 100 years ago. Some of his advice is a little dated now, just because English has continued to evolve as a language, but much of his advice is still really, really good. So programs must communicate to people. There's some people who think, as long as the compiler understands what I meant, that's all that matters. And that's maybe the least important thing. It's more important that humans be able to understand it because we need to keep that thing working, particularly as we get more and more agile. Programs are never finished, so you can't say it's in the can, it's done. It needs to be always in a form which is always editable. And in order to be editable, it needs to be readable. So we want to use the elements of good composition where applicable. For example, if you have a comma, you put a space after it, not in front of it. Even though the compiler will let you put it in front, there's no reason to do that. It looks stupid. And you don't want to write programs that look stupid. Now, the rules of English are not good enough for software. There were attempts at trying to create programming languages which look like English. And they didn't work because English is not precise enough. You need extreme precision as you're trying to approach perfection. The computers are not smart enough to make sense out of wacky prose, so we need to be much more specific. And so we have new kinds of ambiguities that we need to be concerned about that we didn't need to be concerned about when we're writing in English. For example, we've got parentheses, which can indicate grouping, and they can also indicate invocation. And one way to help us distinguish which of those is going on is when we're grouping, we put a space in front of it, and when we're invoking, we don't. So in these examples, foo is a function, so there should not be a space. That should be adjacent. And return is not a function. In some languages, it could be a function, but in JavaScript, it's not. And so we should make it clear it's not a function. There should be a space there. And here we have an anonymous function, but it looks like we're calling a function called function, and that's not what we're doing. So we should put one more space in there to make it clearer. Now, you could argue that the reader ought to be able to figure this out. And in fact, the reader can. You could figure out all these bad examples and make sense out of what was really going on. But that is not where the reader should be spending their time and energy. They shouldn't be trying to get past your syntax and your lousy grammar. They should be trying to understand the thoughts and the structures of the program so they can make it work. In JavaScript, we've recently discovered that immediately invocable function expressions are a really useful form. But there's a syntactic hazard in that you can't put them in as the first thing in a statement because of an ambiguity in the language. That if the word function appears in statement position, then that's assumed to be a function declaration. And you can't immediately invoke a function declaration. I think you ought to be able to, but you can't. So the way we get around that is by putting parentheses around it, and those parens change it from being in statement position to expression position, and then there's no ambiguity. We know it's a function literal. So I see a lot of people wrap the function in parens. But I think that looks goofy, because what we're talking about is the whole invocation, but we got these things hanging outside of it looking sort of like dog balls, you know, so we have an opportunity here to use the weirdness in JavaScript syntax to help the reader, saying, no, what's important is the whole invocation. So I would put the parents around it. That's better, I think. So we can see everything between the parents should be treated as a unit, which is the function being invoked. That's what we're talking about in this expression. Now there's another hazard in the language. We've talked before about automatic semicolon insertion. Here's another example of that. We can have almost any statement before this immediate function, and it will be misinterpreted. Instead of setting x to y and then doing our function thing, it will treat y as a function and pass the other function to it as a parameter. Now that's screwed up. So yeah, it is majorly screwed up. So the moral of this is, do not rely on automatic semicolon insertion. Put all of the semicolon insertions in all of the places where they're supposed to go and nowhere else. Because if you don't, things like this happen to you. And this is another thing where you could read this code for hours and go, I don't see what's wrong with this. Now, if you put it in JSLint, it'll tell you right away what's wrong with it. And that's why you should pay attention to everything JSLint tells you. JavaScript has a with statement, which is terrible. It was a nice idea, it was well-intentioned, but it just doesn't work right. So we've got this green with statement. It does one of those. Can anyone tell me which one it does? Yeah, it does all. Well, you can't tell. It could do any of them. In fact, every time this statement is executed, it could do a different one. So there's no way you can tell, reading the program, what it's going to do. So when JSLint's looking at a program trying to figure out what's wrong, it says, oh, you've got a with statement. That's your problem. Stop using those with statements. You don't need it. There's nothing you can do with a with statement that you can't do as well without one. So just don't do it, and you avoid the confusion that this causes. Now, some people argue, well, yeah, I know with is screwed up, but still, sometimes it's really useful. And you can do these really clever, useful things with it. And I'm not saying it's not useful. I'm saying there's never a case where it isn't confusing. And confusion must be avoided. Confusion is the enemy. The confusion is what causes bugs and security mishaps and all the other things that make us miserable. We want to be precise and clear and clean and elegant and simple. We don't want confusion. We can't afford it. JavaScript has a broken double equal operator. Brendan knew it was broken. When the language was standardized, he was trying to fix it in the standardization committee. Microsoft insisted, no, it stays wrong in the spec. So we still got it. Fortunately, Brendan was able to get triple equal in kind of late. So I recommend always use triple equal, never use double equal, because triple equal avoids these stupidities. Now, some people will ask, well, what about in the case where double equal actually does what I want? Can I use it in that case? I recommend no, don't even use it then. Because someone who's reading your program, they have to stop and ask, is he using it because this is one of the rare cases where it actually makes sense? Or is he just incompetent? Which is it? And maybe it's undecidable. Maybe he's read other things you read and go, I don't know. So don't use it, because it's hard to tell if it's being used right. So anything which is indistinguishable from a common error, if there's a better alternative, go with that. If there's a feature of the language that is sometimes problematic, and if it can be replaced by another feature that is more reliable, then always use the more reliable function. The cost is zero. The benefit is you avoid a whole class of bugs and confusions. Another good trade-off. Multi-line string literals. This is a new feature in the language, was added in ES5. I don't like this feature for two reasons. One is it breaks indentation. We have deeply nested structures in our programs, and this breaks it. The text has to go over to the left margin, and so it makes the program harder to read. It really does. But there's a worse problem than that, in that there's a syntactic problem. So the first one is okay, and the second one has an error in it. Can anyone spot the error?
Long reserved word?
No?
Space.
Yeah. there's a space here. I mean, it's obvious once it's pointed out, right? But I don't want to be putting things in my program that I cannot distinguish from errors. I want my program to be obviously right, or at least obviously trying to achieve rightness. I don't want to be putting things which are clearly wrong. That makes it much harder to spot the things that are really wrong. So avoid forms that are difficult to distinguish from common errors. So sometimes, but I did that on purpose. I'm intentionally using this thing that looks wrong. I don't even have to answer that, do I? I mean, it's just stupid. Often I hear people saying, it's okay because I know what I'm doing. If you knew what you were doing, you wouldn't be doing that. This is a common bug. Okay, so, and you see this in most of the C-like languages. We've got the first statement, which appears to be doing what that one does, but actually does what that one does. And so when you're reading this program, you have to stop and ask, okay, which did he mean? Did he mean, did he accidentally get it right or not? All we know for sure is that the programmer is incompetent. Beyond that, we really don't know what he's thinking. So my advice is don't write the top one, write one of these two. Figure out which one of these you mean and write that. Make it clear. We have a problem in JavaScript with scope. Well, it's not really a problem. Scope is the idea that you've got some block and anything that's declared, any variables declared inside of it are not visible outside of it. That turns out to be a really good thing. It came with Algol 60. It's one of the great ideas in programming language history. Most languages have something that's called block scope, where any block defines a scope. So any variable you declare inside that block is not visible outside the block. Nice. JavaScript doesn't have that. JavaScript only has function scope, which means any variable declared anywhere within a function is visible everywhere within the function. That turns out to be okay. You can write good programs just having function scope. The problem is that JavaScript syntax looks like a language that has block scope, but it doesn't. And so that's confusing for people who learned programming in a different language, like in Java or C or C++ or any of those others. They come to JavaScript, they get confused about what the visibility of variables are, and confusion leads to errors. So that's a bad thing. So in a block-scoped language, the advice is declare the variable as close to the first use as possible. That's good advice in those languages. In a function-scoped language, that is really bad advice. You should declare the variables at the top of the function because that's what's actually happening anyway. So let me show you what's actually happening with a variable statement, with a var statement. A var statement gets split into two pieces. The var part gets hoisted to the top of the function and initialized to undefined. And then the initialization part stays where it is and later gets executed. So if you declare a variable inside of a block, it doesn't get declared inside of a block. The declaration part gets hoisted up to the top of the function, so it actually gets declared at the top, so it's visible everywhere within the function. Again, not a bad thing, except the syntax suggests that that's not what's happening. So because of that confusion, I recommend declare all of your variables at the top of the function. And also, while we're at it, declare all of your functions before you call them. JavaScript has these hoisting tricks which allow you to not do those things, but confusion happens because most people don't understand how that hoisting happens. And even if you understand it, the people who are reading your program may not. And so you want to write the program so that they can make sense of your work, so that they can transform your program into something with greater value. And that's hard if the conventions you were using them were causing them to make bugs. So make your programs look like what they do. Now the thing that seems to be hardest for people to accept is the for var statement, where you're declaring the induction variable in the declaration part of, or the conditional part of a for statement, or in the initialization clause. Because that's how you do it in Java. I mean, it makes so much sense. But it makes no sense in JavaScript because that variable is not scoped to the loop. And if you do things which are dependent on the scoping of that variable inside of the loop, your program will fail. It works differently than what you're thinking. And even if you think you understand it, the person who's reading your program may not. I've seen really good programmers get hung up on this. But you just got to tell them you're not working in Java. This is not Java. This is a different language. Write in the language you're writing in. This is a different language. It has different rules, different conventions, different good parts. You need to respect that. JavaScript has global variables. This is the biggest problem in JavaScript. I'm hoping we'll fix it in the next edition. Dave Herman will be here tomorrow morning to tell us about some of the stuff we're going to do here. But for now, we're stuck with global variables. And that's a problem because global variables are evil. They cause all sorts of reliability problems, security problems, really bad thing, and the language is dependent on them. So my advice is to avoid global variables as much as possible. Try to reduce your use of global variables in a program or a subsystem down to 1 or maybe 0. And it's possible to do in JavaScript, which is really nice, that the language provides for its own workarounds. So the few cases where you have to use global variables, I recommend make your global variable names all uppercase. I want my global variables to be as rare as hen teeth, and I want them to stick out like a sore thumb. So I want, all uppercase seems to be the most obnoxious way you can write a variable name, so that's the way I want to write it. So it's really clear, this is stupid. Now, the biggest resistance I see people having to that is that they come from other languages like C, where all uppercase means something completely different. C has a different class of problems. C has a preprocessor, a macro processor on the front end, and it can create, so in the language you can create things that look like variables that are not variables, they're macros. And that is a source of confusion. And the people at Bell Labs really early on discovered that confusion was intolerable. So they established a convention, let's make all the macros all uppercase. That way we can tell which is which. And that convention, having constants all be in uppercase, traveled over to Java for no good reason, because they had finals, so there's no reason to do that. But they did it anyway. And that convention is now coming to JavaScript, where it makes absolutely no sense, because we don't even have final. It's nothing. So my advice is let's use that convention for something that has value in this language, never mind what it might mean in other languages. JavaScript has a new prefix. I don't use the new prefix anymore. I found it's just so problematic. I don't use it anymore. I use object.create now exclusively. But some people still use new, so that has to be respected. But there's this big problem in the language that if you write a constructor function and someone forgets to put the new prefix in front of it, instead of creating and initializing a new object, it clobbers global variables, which is horrible. And it's the worst, maybe second worst thing it could do. It could maybe kill somebody. That might be worse. So that's a really bad thing. So the only, fortunately, that gets fixed in ES5 strict. Unfortunately, ES5 strict is not in IE6, and it's not in IE7, and it's not in IE8, and it's not in IE9. But someday, we'll get some value out of IE strict or ES5 strict, and that'll be good. In the meantime, we have the initial caps convention. So if a function starts with an initial cap, we know it has to be used with new, and that should be the only use ever of initial caps. Having that convention, it becomes possible to read a program and figure out if it's using new correctly, if the constructors are being used correctly. Without that, it's hopeless. There's no way you can read a program and know if it's right. So this is an important convention. In some languages, they don't have this convention. Microsoft still hasn't figured this out. But it's important. This should be respected. Here's another fun thing you can do with var statements. The top statement appears to mean this, but it actually means this. So again, you have to look at it and ask, what was the intention here? And again, all you really know for sure is the programmer was incompetent. So again, figure out which of these you meant and write one of those. Don't ever write the one on top. So write in a way that clearly communicates your intent. That's what we should be doing as programmers. Now someday we may have the let statement in JavaScript, and that'll be nice. Let is like var, except it respects function scope, so there's no more hoisting, and that'll be great. So when that happens, my advice will change from declare all your vars at the top to saying never use the var statement ever again. We're using let from now on. But we're not there yet, and we're not going to be there until we get rid of IE6 and IE7 and IE8 and IE9 and IE10. Plus plus. Okay, plus plus. So this came out of C. It was intended for doing pointer arithmetic, so you could increment a pointer, get to the next thing that was being pointed at. We've since determined that pointer arithmetic is a really bad idea. The last popular language with pointer arithmetic was C++, a language so bad it was named after this operator. But we still have it. So it's in all of our languages now, even though we don't have pointers anymore. And it adds 1 to something. And it is generally used to create side effects. And side effects are a source of confusion anyway. But I found that when I'm writing stuff with plus plus, I cannot stop myself from trying to pack as much stuff into a statement as I can. And I'm not the only one. A generation of programmers has this affliction. Most of the buffer overrun craze in the 80s and 90s, where it was so easy to take over operating systems, was because of this operator. That it just is so easy for the enemy to get something into memory and get it executed, because this encourages you to write stuff which is just way too damn clever, way too difficult to understand. It's bad. So I found in my own practice, I do not trust myself to use this operator ever. Because if I use it anywhere, even in a for statement, I start getting the twitch. And I am trying to push too much stuff in. I'm using commas. I'm doing all sorts of stupid stuff, trying to get it all in one line. I'm trying to optimize a thing which has absolutely no value, has negative value. There's no cost to us today in getting stuff all into one line. And it presents a tremendous cost in terms of reliability, readability, all the good abilities. It's a bad thing. So in my own practice, I say, no, I do not trust myself to use this ever. I use plus equal 1 instead, everywhere, because I'm no good with the other one. And I get people complaining, oh, wait a minute, I should be able to write x plus plus because it's 1 character shorter, and it means the same thing. And saving 1 character here has no value at all. That's not a good trade-off. And in fact, it doesn't mean the same thing, because plus plus x means the same thing. So this actually means something that's slightly different. And something that is slightly different means you've got a subtle off by 1 error that is really hard to detect, because it's only off by 1 for a moment. And so debugging that's really hard. And so when I see someone using that interchangeably with that, I have to look at every plus plus in his stupid program and ask, okay, did he get it backwards or not? Does he understand the difference between pre-increment and post-increment? Because he doesn't there. I don't have time for that. That's just way too much work. I'm just trying to make the program work. I don't want to have to figure out what he's doing. Recently, I was reviewing some code, and I saw this, plus plus x plus plus x. Now, had he originally written x plus equal 1, he could have easily changed that to x plus equal 2, and it would have been great, but that was too much work, so he doubled the line. Or maybe it was a copy and paste error. I don't know. I don't know. It's stupid. I would call a bug on that, but I don't know that it actually is the wrong thing, but it sure looks stupid. And it would cause me to wonder, there may be other really bad things in this program. So for no cost, by adopting a more rigorous style, many classes of errors can be automatically avoided. That is a good trade-off. No cost, big benefit. Here's another one. The biggest design error that Thompson made when he designed B, and Ritchie copied the error in C, and everybody has copied it in everything since then except for maybe Python, was that he made the curly braces optional on these structured statements. He should have made the parentheses optional, but he decided to make the curly braces optional instead. That was a huge mistake. So as a result of that, you've got statements like this where it looks like we're going to conditionally call B and C, but that's not what happens. It looks like it wants to do this, but it actually does that. So this is another one of these confusion things. And I talk to people all the time saying, my advice is put the braces in, put them in everywhere. It's only 2 characters, and it makes your program so much more resilient, and it's so much more likely that someone who's going to be maintaining your program is not going to accidentally break it. Makes your program stronger, less error prone. That's a good thing. You go, but it's 2 characters. You have to go so hard. It's not that hard. And again, they're thinking, we spend all of our time typing. If we can somehow save those 2 keystrokes, we're going to be so much more productive. And we're not. You're going to be so much less productive because you're going to be chasing down problems due to false structures in your code. So as our processes become more agile, our coding must be more resilient. We need to anticipate that this code is going to be changed many, many times and will not break as a result of that change. So we can't do anything that's too tricky, too intricate, because it will not work. Programming is the most complicated thing that humans do. And computer programs must be perfect, and humans are not perfect. So that is the struggle. That is the core problem in our craft. And that is what we do. So designing a programming style demands discipline. We're not selecting features because they are liked or pretty or familiar. We're designing features because we want to improve our error rate. Because we spend way too much time staring into the abyss. And if you want to be more productive, spend less time staring into the abyss. That's what I'm talking about. So the JSLint style was driven by the need to automatically detect errors. I decided that forms that can hide defects are themselves considered to be defects. I had no idea I was going to reach that conclusion when I started working on JSLint. When I started working with JavaScript, I made exactly the same mistake that everybody else makes. So I don't claim to have come into this with perfect knowledge, and I'm not trying to impose my personal standard on anybody. This all came about empirically as a result of trying to automatically detect errors in a deeply flawed language. JSLint taught me JavaScript. I know what I know about JavaScript because JSLint taught me. JSLint is much smarter about JavaScript than I am. It's probably smarter than you are too. So my approach to JavaScript has been subsetting. That any feature which is problematic that I can live without, I will happily live without it. It's been said only a madman would use all of C++. You could also say only a madman would use C++, but I'm not going to argue that tonight. But this approach to subsetting works in every language. It is really easy to add features to a language, and some designers will think of a clever feature and put it in, and sometimes it works and sometimes it doesn't. If it doesn't, they cannot take it out. If a language is popular, if there's significant use, they cannot remove a bad part without breaking things. Even if that part is dangerous and causes people to write bad programs, it's stuck there. You have a power that language designers and standards bodies do not have. You can take features out of any language at any time by simply refusing to use those features. My advice is not that you be ignorant about the features that you don't need. I think it's important that you know the whole language, but that you know enough to know to avoid the features which are working against you and not for you. So there will be bugs. I'm not promising that by using JSLint or using these techniques that you're going to be bug-free. What we're trying to do is to move the odds slightly to your favor. Any bugs we can help you to avoid will make you more productive and happier. So my conclusion, good style is good for your gut, even if your gut doesn't think so. Thank you, and good night. So I think we have time for some questions. Do you want to run the mic, or should I repeat? Okay. Okay.
Has anyone written a JS tidy tool? For example, like if I write a var statement in the middle of my function, I would love some tool that strips out that var and sticks one at the beginning of the function for me, so I don't have to worry about adding 2 lines just because I added a new variable to the function.
So has anyone written a JS tidy tool?
Like Perl has this, and it's beautiful.
Someone may have, I don't know. For a long time, I've been thinking about writing something called JS Max, which would be sort of the reverse of JS Min. It would take something and pump it all back up, and it would do things like that. But I haven't. But maybe somebody else will.
Do you have any comments on CoffeeScript?
Do I have any comments on CoffeeScript? I really like CoffeeScript. I think CoffeeScript is a brilliant experiment. JavaScript's good parts have nothing to do with its syntax. So most of the bad parts in JavaScript are its syntax. It's quite awful. And so CoffeeScript takes the good parts and puts a minimal syntax on top of it, which is lovely. So I like CoffeeScript a lot. I don't recommend using it in production because it comes with its own world of problems, and I don't think that's a good trade-off. I would like to see JavaScript move in the direction of CoffeeScript in the long run. There are a lot of pressures on the language, and I'm not sure it's ever going to get there, but that would be my preference if we could. Anyone else? Going? I'm sorry? Google what? Oh, Dart. So I've thought for a long time, if I could take a clean sheet of paper and write a language, a new language, which corrects every defect in JavaScript, but retains all of the goodness in it because there is a lot of goodness in it, I would not have come up with anything like Dart. That's not to say that there aren't some good ideas in Dart, but it doesn't capture the goodness of JavaScript. It feels like it's trying to go back and be more Java-like. And its syntax stinks. I don't get it. There's something wrong over at Google. I don't know what it is. Apparently there are a whole lot of guys over there who think it's a good idea. I don't know what's going on.
Are there any other languages you would borrow any other goodness from to add to JavaScript?
I'm not an advocate of trying to make JavaScript bigger. I'm actually going the other way. I'd like to make it smaller. If I could, my goal for the next edition of the standard, which will not be met, but my personal goal is to make JSLint unnecessary. We're not going to accomplish that. Instead, we're going to add a lot more stuff, which will probably introduce more bad parts unintentionally. That's just how this stuff happens if you try to add too much stuff too quickly. JavaScript sort of miraculously combined functions as first-class objects with lexical closures and dynamic objects with prototypal inheritance. Two things that were never put together, two experimental ideas, and put into the mainstream, wrapped in a familiar syntax that worked. It's ingenious. I love that about JavaScript. And I think that's enough. I mean, there's enough there. And anything else it needs could be added as libraries.
You didn't mention it tonight, but JSLint also has a thing against, I forgot how you put it. If you use a foreign but you don't have a has-own property check in it.
Yeah, so JSLint complains about unfiltered for-in statements.
Doesn't that filtering defeat a lot of the benefits of prototypal inheritance though? Like one of my beefs with YUI is that they do this. If you use prototypal inheritance to define your configuration object, YUI will reject anything that configuration object has inherited from the parent object, which was really frustrating until I realized that's what was going on, because it seems so counterintuitive. It's this great thing in the language, but I can't use it. And even object.keys has this, what seems to me, a flaw.
Well, no, it's not a flaw because it's so hazardous. So again, the argument is it's not that it isn't useful, it's that it's dangerous and error prone. So the reason I'm recommending you not use it isn't because you can't figure out a clever use for it. And I admire you for having found a clever use. I still recommend you not do it.
So why in the catch statement you have to use a different variable name?
So why in the catch statement do you have to use a different name in every catch?
Yeah.
It's because in some browsers, and I don't need to iterate through that list again. All of those become the same variable. The correct way to do it should be to make every catch clause, every catch block, be a separate scope. But in some browsers they don't. So you might think that each one of these is a unique variable, and they should be, but they're not. If they all have the same name, they are all the same variable. And that is a confusion, and we don't want to be confused. Okay, so that's that. Thank you very much, everybody. Be careful going home. Good night.